with the question, a race. Alice and Bob participate in a TV game show. When the game starts, the prize will be dropped at a certain point, and whoever gets it first will get the prize. Alice decided that she would start running from point A. Bob, however, has not yet chosen his starting position. Bob knows that the prize could drop either at a point X or Y. He also knows that he can reach the prize faster than Alice if the distance from his starting point to the prize is strictly less than the distance from Alice's starting position to the prize. The distance between any 2 points C and D is calculated as C minus D. So your task is to determine whether Bob can choose an integer point that is guaranteed to get to the prize faster regardless of where it appears, at a point X or Y. Bob can choose any integer point except for A. Okay, so basically in this question a game is going on in which Alice and Bob have to run from a starting position, so they have to choose their starting position beforehand. So Alice's starting position would be A, and that is fixed. Right, now Bob has to choose the starting position. So Bob has an idea of where the price might fall. It might fall at X or at Y. So B can choose any position, any integral positions that is closer to the price X or Y, but B cannot choose A as its position. So let's see the first test case. So the test case is in the form of A, X and Y. So A is 1, X is 3 and Y is 4. If Bob chooses position 4, then there will be 2 cases where the price would fall. So the price is going to fall at either 3 or either 4, right? So if it falls at 3, then the distance calculated between Bob's position and the price's position would be 4 minus 3, that would be 1. The distance between the price and Alice's position would be, price position is 3, and when we subtract it would be 1, and we get 2, which is greater than Bob's position, so Bob is going to win. So when the price falls at position 4, then when we calculate the distances, then Bob's position would be 4 minus 4, and that would be 0 because he is standing at 4 and the price also falls at 4. Okay, and Alice's position would be 4 minus 1, that is 3, and it's greater. So in both the cases, whether the price falls at 3 or at 4, Bob is going to win. So hence the output is yes, that Bob will win. Okay, let's look at this test case on a number line. Let's visualize the test case. So 1 is Alice's position, 3 is X, and 4 is Y, right? So these are the 3 positions. So in order to be closer to X and Y, Bob needs to choose a position that is here. So he will be closer to X and Y both. So if he chooses either 2, so he will be closer to x, as this distance will be 1 and this distance will be 2, right? And which is always smaller to Alice's distance. Okay, as for Alice, this distance is going to be 2 and this distance is going to be 3. So 1 is less than 2 and 2 is less than 3. So in both cases Bob is going to win. So he can take any position. He can take either 2, he can take either 3, or he can take either 4. All these are integers and these positions can be taken. So Bob can take this position. Okay, so this becomes the case where x and y lie ahead on the number line from Alice. Okay, now a case also can be that this is x and this is y and Alice's position lies ahead. Okay, and in this case Bob can take any integral positions between here that will give the minimum distance. Okay, he can take x and he can take y, and then Bob will be still be closer to the price than Alice. Okay, now let's see where else the position of Alice can lie. Okay, it can happen that here is x, here is y, and Alice's position is at the center, or Alice's position is at x or y. So what will happen in this case? In this case, no matter what position Bob takes, it will always happen that Bob is going to lose in one case, right? For example, if here is an integer position and Bob is here, so he is closer to x and he is going to win if the price is at x, right? And Alice will lose as she is far away. But in case y is the price position, it's not x, then Bob's position is going to be greater than Alice's position, right? So only in this case Bob is going to lose, either at if the price falls at x or price falls at y. Let's take an example for all the cases. So for this case we have seen that if the position of Alice is on the left hand side, let's see if it is on the right hand side. So let's take x as 1, let's take y as 2, and let's take Alice's position as 3. So when these positions are given, if we take Bob's position as y, let's take Bob's position as y. So in the case when price falls at x, if the price falls at x, then the distance of Bob is going to be 2 minus 1, while the distance of Alice is going to be 3 minus 1. It's 1 and it is 2. So here Bob wins, and if the position of price is y is equals to 2, then Bob's position the distance of Bob and the price is going to be 2 minus 2, that is 0. And Alice's distance is going to be 3 minus 2 is 2, that is 1. Okay, so what we have to keep in mind is, if Alice's position is greater than the maximum of x or y, or it is less than minimum of x or y, which is on the left hand side and this is on the right hand side, that means that Bob is going to win. And if let's see this using an example, this case using an example. So let's say if Alice's position lies at y. Okay, so this is, let's take it 3 and let's take it 5. Okay, so this is also Alice's position. Now, no matter Bob takes any position, like for example he takes a position at 3, this is Bob's position. So if the price falls at 3, then Bob is going to win, because the distance would be 3 minus 3, that would be 0. Okay, and Alice's position is going to be 5 minus 3, that is 2. Okay, so here Bob is going to win. But what happens if the price falls at 5? So at this point Bob's distance would be 5 minus 3, which is 2, and Alice's distance would be 5 minus 5, that is 0. So here Alice will win, no matter the position of Bob. If Bob is here or if Bob is here, if he is at 4th position, doesn't matter. He is going to lose in this case when y is equals to 5 is the position of the price. So what two things do we have to keep in mind for this question? First thing is, if Alice's position is less than minimum of x or y, that is to the left of both x and y, or Alice's position is greater than maximum of x and y, that is to the right side of both x and y, then we will output yes. And else, if Alice's position is less than or equal to maximum of x comma y, or less than or equal to minimum of x comma y, then Alice is going to win and we'll output no. Okay. Okay, so let's see the code for this question. Okay, so we are going to input a, x and y. If a is greater than or equal to minimum of x and y, okay, so this is the version minimum of x and y. It could be a point that x lies here and y lies here, right? So minimum of x and y, so y is the minimum, so a is greater than y and less than equal to maximum of x comma y, and in this case it is maximum, x is maximum. Okay, so y equal to, because Alice's position can also be at x and at y as well. So if this is the case, we are going to output no, else we will output yes. So I hope you understood this question, and if you have any doubts, you can post it in the comment section below. Thank you.